Hello, friends. This is Jim with Science Talk, and I want to share a quick little interesting article with you. I'm waiting for my PowerPoint here to do what I want it to do. There we go. Okay. So, what are we looking at here? We're looking at a 180 million year old Ichthyosaur, which literally means fish lizard, fossil that has been discovered. So on the top here, this is the actual photograph of the specimen, and down here is a diagrammatic representation of the photograph. And this is 85 centimeters in length, so it's nearly a meter in length. And what's really interesting about this particular specimen is that its blubber and skin were preserved. Now, I just did a segment showing you some really cool photos of a nodosaur found. Well, it seems like these things are popping up all over the place, which is cool. So this is a report that can be found in the journal Nature. The blubber, which is a layer of fat beneath the skin of marine mammals like seals, whales, basically pinniped cetaceans, help preserve heat because water will suck heat out of an organism a lot faster than cold air will. So the presence of this blubber indicates that this ichthyosaur might have actually been warm-blooded. Oh, that's cool. Now, we've usually been told, oh, reptiles are slow, lumbering creatures. They're cold-blooded. More and more, we're starting to see that it's not so clear-cut and dry. It's a spectrum. It's a gray area. So it's not clear-cut. Oh, this organ is cold-blooded. It needs the heat. You know, the body temperature is the ambient body temperature. It needs the heat of the sun to warm itself up. This creature is strictly warm-blooded. It maintains a constant body temperature no matter what the ambient temperature is. And now we're starting to see that there's a gradation. You know, some bits of warm-bloodedness, some bits of cold-bloodedness, what have you. Tunas and sharks are said now to be warm-blooded because they do maintain a body temperature that is greater than the surrounding water temperature. Sometimes the body temperature, even though it's warmer than the surrounding, is not the same. It's still nevertheless warmer than ambient. So this ichthyosaur appears to have shared qualities of both a mammal and a reptile. This is according to Johan Lindgren, who is a senior lecturer at Lund University in Sweden. The tail fin is vertical, not horizontal, that we find in dolphins and whales. They were definitely reptiles. The dolphins, of course, are mammals. Ichthyosaurs were reptiles, but now it's showing that they're showing some characteristic that seem to share certain aspects with mammals. That's really cool. So Professor Lindgren basically says, in most aspects, I would say they were living like dolphins. They were really dark, almost blackish. I would imagine a kind of a dorsal skin, and some forms were deep divers that could venture down to perhaps several hundred meters and then come back up. Several hundred meters is, we're talking about like 1,000 feet. So we got this really cool, this is a photograph of the creature in question. Here's the diagrammatic thing. You can see the eye bones here, some fin rays. You know, looks like some ribbing here, other bone bits. And this is all part of the skin. Looks like some appendage bones, etc. Let's see what the next slide is. So this is a comparison of, porpoise integument and fossil ichthyosaur blubber. So you can see the blubber indicated here and here, here and here, and this is the skin. So the blubber would be the beneath the skin, providing an insulatory layer. So here's the skin, then here's the blubber. So this is like a cross section. This is a cross section. This is a longitudinal section, and this is an end-on section there. So this is what we're looking at here. So we're seeing evidence of blubber. So how do they know it's blubber? They probably subjected it to some X-ray diffraction technique where molecules can will bend light in a certain manner. Lindgren also said that they found pigment cells concentrated on the dorsal side of the creature's body, indicating this animal was originally counter-shaded, meaning it had a dark upper surface and a light belly. Right? And we see this sort of camouflage in modern animal groups today, terrestrial, marine, what have you. So let's see if I can show you. Yep, here we are. So here are the pigment cells. Okay, so this is a light micrograph using basic, typical lighting in the spectrum that we see in. You can see here are the melanophores. Melanophores contain the pigment, so that's right here, here, etc. All these dark blotches. And then in the center is an X-ray of the melanophore, showing even greater detail. Sea minerals appear to have helped preserve and fossilize the creature's blubber. So what happened here? And this is another case where the organism upon death was rapidly buried so that such features as the blubber could be preserved. They were entombed, the thinking is they were entombed in calcium phosphate, and that entombment apparently preserved the tissues. Fossil dates back to the Jurassic era, 180 million years ago. Said the co-author Mary Schweitzer, who is a professor of biological sciences at North Carolina State University. Professor Schweitzer has done a lot of really amazing DNA analyses of various paleontological finds. She just does some incredible work. So Schweitzer was studying, said studying this fossil could help explain biological diversity, what makes animals thrive. We cannot, we cannot predict the future of our planet without understanding the past. That's where data lie. I just did a video segment that the key to understanding the present and the future is understanding the past. Now, that particular video was looking at hints of the past climate, but that's pretty much true for just about anything in science. Want to understand what's happening now and possibly will happen in the future, you got to understand what happened before. So the next slide is the actual fossilized skin right here, and it's forming a trailing edge of the right pelvic fin, which is up here. So that's some of the bone material there. So this is skin. Pretty amazing stuff. Well, anyway, this is a nice short little video. I just wanted to share with you again some more cool finds. Fascinating stuff. And anyway, hope you found it interesting. Thank you for your time. Hey folks, this is Jim here reminding you to subscribe to this channel, to share my videos, tell others of the work that I do here. I also ask that if you are not already a patron at Patreon, to please consider becoming a patron at Patreon. You can find the information in the description box below the video. I'm asking you to help support the work that I do. I do not take any money from corporations or from any other sources, so the information I share with you is the actual science as it comes out of the peer-reviewed journals. So there is no BS, there's no propaganda, there's no agenda. It's just I present the science and I explain to you what it means, or at least my interpretations of it, based on my own experience as a scientist. I want this channel to grow. I consider, while I discuss many different topics here, you notice I do focus a lot on climate issues. I consider climate change to be the most pressing issue facing humanity today. Thus, I consider it important to disseminate this information to a wider and wider, more and more people. And I need your help to do this. So, yes, please subscribe. Please tell others of the work that I do here. Please share my videos on social media platforms, with your social media groups, what have you. We need to get this information out there. So for those of you who are supporting me on Patreon, I thank you greatly for your support and continued support. It does mean a lot to me. So together we can get this information to more and more people. Thank you. Thank you for your support.